Hello everyone. In this video, we're going to go through entire chapter 1. This is the very beginning chapter of the course. It has a lot of terms and definitions, so I'm going to go through those more quickly and then spend more time on calculating part. Okay, so the first part on chapter 1.1, we have a couple vocabulary terms. So let's fill in the blank. The blank are a collection of observations such as measurements, genders, or survey responses. We call this data. Blank is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion based on them. This is statistics. So this is basically what we are going to be learning throughout the course. We will be planning some experiment. We have to obtain the data and then use that data to organize and then analyze. And from that data, we interpret and then draw conclusion. Okay, so the whole entire semester is about doing that process. Okay, the next term, a blank, is the complete collection of all measurements or data that are being considered. We call it population. The next 4 terms, I'll go through those and then give you an example. Okay, a census is the collection of data from every member of the population. A sample is a sub-collection of members selected from a population. A blank is a numerical measurement describing some characteristic of a population. We call that parameter. And the last one, a blank is a numerical measurement describing some characteristic of a sample. We call it statistic. Okay. Now, the last 4 terms are a little bit confusing and the definition seems kind of similar to each other. So I'll give you an example. Well, population is an entire set that you want to consider when you are conducting an experiment. So for example, example for a population could be a whole entire US adult. Okay. Now, although you are doing an experiment based on the whole US adult, it's impossible to gather data from entire US adults. So what happens is we draw a subset, smaller set. So that's a sample. Okay, so we pick a reasonable size, let's say 200 people. Now we use letter N for the sample. This is just a universal letter for sample size. So we take 200 people and then obtain the data. Now that's more reasonable because 200 people, managing that is a lot more easier than getting the data of the whole entire adult, US adult, which is a really big number. Okay, so that's what the sample is, subset. Now, parameter and statistic. Parameter is a numerical measurement describing some characteristic of a population, and statistic is a numerical measurement describing some characteristic of a sample. So let's say out of 200 people, let's say you're conducting a study that average US adults, the weight of the average US adults. So you gather 200 data and then average them and find that female US adults weighs about 130. Okay, I'm just making a number, the 130 pounds. So that's statistic, numerical measurement describing some characteristic of a sample. We gather that data. Parameter is the numerical data about the whole entire population. Let's say when you actually gather the whole US adults, the weight is about 127 pounds instead of 130 pounds. Now there's a difference, of course. That 200 sample is not going to give you a perfect measurements for the entire US adults, but it gives you an idea. So parameter and statistic is a different value. Now you want to select the sample nicely so that this data statistic is reliable and then very close to the actual parameter value. And we are going to talk about how to select samples more nicely so that we don't get biased result and then we get more accurate data. Okay, so that's pretty much it. Now also one thing I want you to note is the difference between statistics and statistic. There's a S. Statistics is like the subject, what you are studying. Statistic is a numerical measurement. So there's a difference between the two. Okay, so let's go through first example and then identify the parameter value and statistic. In Harris poll, 2,320 adults in the United States were surveyed about body piercing, and 5% of the respondents said that they had a body piercing but not on the face. There are 241,472,385 adults in the United States. The results from the survey are sample drawn from the population of adults. So we have couple numbers. So I'm going to highlight it. So there's a first number, 2,320. There's also 5%, and then 241,472. 241,472,385. So I'm gonna give you a minute to see if you can identify the parameter value and statistic value. Right, so let's begin with 2,320. What is that number? So they only did the poll of 2,320 adults. That is not a parameter, because first of all, parameter is the entire population and there's more than 2,320. So you can eliminate that it's not a parameter. Now, is it a statistics? Why not? Well, 2,320 adults in the United States were surveyed. So that's the number of people who took the survey. So going back to that definition that we talked about, that's actually a sample size. N equal to 2,320, that's actually a sample size. So what is then statistics, right? Well, let's keep going. 5% of respondents said that they had a body piercing but not on the face. So that's an actual result number. And then there are 241 million. That number is actually the entire set. So that's a characteristic of a population. So parameter is the big number. So we got that, and then this one we identify as a sample size. So that 5% is actually the statistic. So it tells you the numerical measurements describing some characteristic of a sample. The 5% of the respondents said that they had a body piercing. Again, some characteristic of a sample. So you're going to take the 5% of what? The surveyed number. So 5% of 2,320. Now that's approximately, using a calculator, 2320 times 0.05, 116. Okay, so here you have to do some little bit of a calculation. Now when you write the statistic, don't just say 5%, because when you say 5%, I don't know what 5% of. Is it out of 2,320 or the 241 million? So make sure you write the whole whole thing and then calculate it. So it will be 116. Again, don't get confused between the sample size, which is 2,320, and the statistic value. Okay. Okay, let's move on to 1.2. So 1.2, section 1.2, we are going to look at some data and then how to collect the samples. So there are two different types of data, quantitative, qualitative. Quantitative is data consisting of a number representing counts or measurements. So anything that deals with the number involved, we call it quantitative. Now quantitative, we have two different types of quantitative data, discrete and continuous. Discrete data is a finite, countable. Continuous data is infinite, not countable. So to make it a little bit easy to remember, I just think of discrete data like a whole number, finite, 1, 2, 3, 4, you can count. Continuous data, I call it like a decimal number, like 1.1. But you can also have a number 1.125, right? There's infinitely many numbers just between 1 and 2 in a decimal number. So that's the huge difference between the two. An example of a discrete data is an IQ score. IQ score are always measured in a whole number. Example of a continuous data is a length of an object. Okay, from 0 centimeter to 5 centimeter. There are a lot of objects that fits between 0 to 5 centimeter. And it's not always going to be like 1 centimeter, 2 centimeter. An object can be 1.25 centimeter. So that's the continuous data. Now I want to talk about the discrete data a little bit more. Now I just mentioned that it's a finite countable, but discrete data can have infinite type as long as you can count. What does that mean? Well, let me first write down. So discrete data can have infinite form as long as you can count. Okay. What does that mean? Example, let's say you want to look at the number of trials to get 2 when you are rolling a die. Okay, so number of trials to get 2 when rolling a die. Okay, so you roll a die for the first trial, you didn't get 2. So what do? You roll the second one, you didn't get 2. You roll the third one, you finally got 2. So you go back and then count. Oh, first one I didn't get 2, second one I didn't get 2. Oh, I got on the third trial. So you actually count the trial. However, when you roll a die, you really don't know when you're going to have that 2, when you're going to have a 2. So that's kind of like infinite. You could have landed on 2 in the first trial. You could have rolled a die and then have a 2 on the 10th trial. We don't know. So that's like the infinite type, but you can count. So in that case, that will be an example of a discrete data. Qualitative data is data consists of names and labels that are not number representing counts or measurements. So these has to do with non-numerical but names and labels. So example of a qualitative data is like a car brand. Okay, we never use a number. Car brands, Honda, Toyota, Lexus, and so on. Another one, eye color. Eye color are involving names and labels. Blue, hazel, brown. Hair color is also another qualitative data. There are a lot more, but I'm just giving you some few examples. Okay, so quantitative, qualitative. Okay, let's go to next page. So once you have the data, where's the data coming from? Well, you got the data from your samples. How do you pick your sample? Well, there are a couple ways to select the samples. So let's go through that one, sampling method. Now, some of them are good sampling method and some of them are bad sampling method. So let's go through each. Random sampling. Each member of the population has an equal chance of being selected. Computers are often used to generate random telephone numbers. Simple random sampling, a sample of n subject is selected in such a way every possible sample of a sample same size n has the same chance of being chosen. So basically you are picking your these two means you are picking the sample randomly. Okay. You give each person a number and then computer pick a number, that's your sample. Everyone has an equal chance of getting picked. Okay. Now, the term random sampling is for the population. Simple random sample is for sample and subject. So that's the difference. But basically, they're saying that we pick a sample randomly. Systematic sampling. What is a systematic sampling? Select some starting point, then select every kth, such as every 50th element in the population. So basically, you line up all your population, you pick a random number, third. So you count 1, 2, 3. That's your first sample. 4, 5, 6. So that's your sample. 7, 8, 9. That's your third sample. 10, 11, 12. That's your fourth sample. You keep going until you have enough samples. Okay. This is also a good sampling method. These two are good sampling methods so far because you are not eliminating anyone. You are just picking randomly. Next one, convenience sampling. Use results that are easy to get. Just from the description, it's really condensed and then it doesn't tell you much, but you can kind of see that it's not going to be good because use results that are easy to get. This is actually a bad sampling. You don't want to use a convenient sampling. So here's what I'm saying. Let's say you want to know how many hours students study. So you go to a library, wait outside, and then pick first 10 people that get out of the library and then ask them how many hours during the week that they spend studying. So that's a bad sampling. Why? Well, you are first getting the data from the library, people who actually came out from the library. So it gives you a biased result. Why? Because there's a tendency that people spend more time studying when you go to the library. So you're not getting the whole distribution of the population. Second, you are just standing in front of the library, just one place. So again, instead of maybe picking a sample from college cafeteria or gym and library, they may give you a different data. So you want to get the data from different areas, not just one place. So that's an example of a convenient sampling, and we do not want that to happen. Next one, stratified sampling subdivides the population into at least two different subgroups or strata, so that subjects within the same subgroup share the same characteristics such as gender or age bracket, then draw a sample from each subgroup. So basically, you have the whole population divided into some groups known as strata. So here's an example. They divided into two parts, Democrats and Republican. So there's one group here, and then there's another group here. Then within the same group, share same characteristic, draw a sample from each subgroup. So you pick few from the Democrats, you pick few from Republican. So there's 3 coming from here and then 4, and that give you the entire sample size. Okay. Cluster sampling. This is a very similar to stratified. Okay. Divide population into sections or clusters. So that's kind of like the same thing with the stratified. You divide it first into groups. Then randomly select some of those clusters and then choose all members from those selected cluster. Now here's a key clue. All members from those selected cluster. Stratified, we had a group. We didn't pick whole entire Democrat to represent our sample. We picked few from the Democrats, few people from Republican. Whereas cluster sampling, you are dividing into subgroups. So architecture section 1, art history section 1, art history section 2. So there will be a students in that sections. And then what happens is you pick a cluster, call it art history section 1, and take all sample from that cluster. And then you go to the next cluster. Oh, I'm picking biology section 2. Then from that, you take all samples from the biology section 2 and then makes up the group. So hopefully you know the difference between stratified and cluster. And these are both good sampling. So good. Okay, let's move on to frequency table, and levels of measurements. So these are more example of a data, types of a data. Now we have 4 different levels of measurements: nominal, ordinal, interval, and ratio. Nominal being the very bottom, and then it goes up this way. Okay. Well, so let's begin with the bottom level of measurements. Nominal. What kind of data are nominal? These are the categories only. Data cannot be arranged in order. So again, hair color. Okay. Categories, names and labels. We cannot arrange the data in the order. We just have different hair colors. Blue, brown, black, blonde, right? But we don't really place the blonde before brown or something. Okay. Types of movie. Okay, again, it's just different types, categories, but we do not place in some certain order. Okay. Now, for nominal, this is like, what does it sound like? Qualitative data. So nominal is a qualitative data. We talked about the quantitative versus qualitative, so this is qualitative data. Ordinal. Data can be arranged in order, but differences either can be found or meaningless. So now you can start putting things in order. So what kind of data do we have such that we can place in order, but we cannot see the difference between the first position and second position? So let me give you a minute to think about this. So an example of an ordinal is days of week. Days of week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now there's a definitely order, right? We always say after Sunday comes Monday, after Monday comes Tuesday. So there's a certain order, but we really cannot find the difference between the Monday with the Sunday. We cannot subtract and get a value. So that's an example of an ordinal. Another one, colors of rainbow. There's a certain order that you see in the colors of rainbow. And then last one, alphabetical order, last name, okay, A through Z. After A comes B, comes C, comes D. Okay, so alphabetical order. Again, ordinal, if you look at days of the week, colors of rainbow, alphabetical order, these are all names and labels. So this is also a qualitative data. Next one, interval differences are meaningful, but there is no natural zero. Now you can find the difference. So difference in mathematic term is a subtraction. So there's a number involved for the interval. So you can see that this is quantitative data. Same thing with the last one. There's a starting point ratios are meaningful. So this is also a quantitative data. Numbers involved. Okay, now I'm gonna go through interval and ratio at the same time, give you an example at the same time, and then tell you the difference between the two, because it works easier if you look at the example both at the same time. Interval difference are meaningful, but there's no natural zero, so there's no zero involved. Ratios are meaningless. Ratio means in mathematics like twice, right? Multiplication or half division. Ratio level, there is natural zero starting point, and the ratio are meaningful. So example for interval is a temperature. And then ratio, length of an object. Okay. Temperature. Let's say you have today's temperature is 70 degrees. Tomorrow it was 80 degrees. You can find the difference between the two. Oh, tomorrow will be 10 degrees higher than today. Whereas ratios, we don't say, oh, actually, let me pick a number that is more easier. 40 degrees versus 80 degrees, okay? You can find the difference between the two. There's a difference of 40 degrees, but ratio are meaningless. Well, there's a twice. The number goes twice, double, but that twice doesn't mean anything in the temperature. Why? We don't really say, oh, 80 degree will be twice as hot as 40 degree, right? So that's what it means by difference are meaningful, but ratio are meaningless. We don't say, oh, 40 degree is half as cold as 80 degrees. We just have a 40 degrees, 80 degrees, and then those mean different thing. Whereas length of an object, let's say you have a 10 centimeter object versus 20 centimeter object. Well, you can find the difference. There are 10 centimeters difference. But you could also say 20 centimeter object is twice as long as the 10 centimeter. So that's what it means by ratio are meaningful. This time you can definitely say the 20 centimeter object is twice as long as 10 centimeters. Okay, so there's the example for nominal, ordinal, interval, and ratio. Okay. Now let's talk about the frequency distribution for the next part. Frequency distribution. So the rest of them tells you a little bit of how to organize the data. In chapter 2, we are going to talk about a couple more ways to organize the data. But let's go through frequency distribution, pie chart, bar graph, and Pareto chart. Few ways to organize the data. Frequency distribution. A list of data values either individually or by groups of intervals along with their corresponding frequency or count. When we construct a frequency distribution, we arrange data in descending order, tally each occurrence. Here's an example of a frequency distribution table. Here is IQ score and then frequency. So IQ score 80, between 80 to 89, there's a 5 data values. Now, we really don't know that 5 data value specifically. That 5 data value could be like 81, 81, 82, 87, 89, right? But I just know that there are 5 datas of IQ score between 80 to 89. 90 to 99, we have a 6 count of a data. IQ score between 100 to 109, 4 data. There's 2 datas of 110 to 119, 3 datas of 120 to 129. We call these classes. So in this particular frequency distribution table, there are 5 classes. This number that begins the class, we call this one lower class limit. And then the top number, we call it upper class limit. Now, when you are dividing the classes, never repeat the lower and upper class. So let's say you have an 80 to 89. The next number should be 90, not 89. Because if you repeat the number, let's say you have a data of an IQ score 89, you don't want to double count. So make sure lower class and upper class limit is a different value. So frequency, so 3 types. Frequency, relative frequency, and cumulative frequency. Frequency is the actual count. 5 data, 6 data. Now, what is a relative frequency? Relative frequency is a proportion or percent of a data value. Okay, out of 10 data, I have 5 data that has IQ score 80 to 89. Then you can see that, 50% of the data is IQ score between 80 to 89. So that 50, that's a relative frequency, proportion or percent of a data in a categories or interval. We calculate the relative frequency by having a class frequency divided by sum of all frequency. 5 divided by 10, 50%. Cumulative frequency is a frequency of an interval plus all previous frequency. You see the word cumulative frequency. Word cumulative means from beginning all the way up to a certain point. So you're going to be sum up all those previous frequency. There's also called frequency cumulative relative frequency. So that one is you're going to be accumulating the relative frequency value. So next example, next page, I'm going to show you how to calculate all of them. Okay. Construct the relative frequency and the cumulative frequency table using example 1. Okay, so example 1, which is this one over here, they give you the frequency. So let's actually put that number down. It was a 5, 6, 4, 2, 3. Now, how do we calculate the cumulative frequency? Class frequency over sum of all frequencies. So for the cumulative frequency is number 2. This is a frequency of interval plus all previous frequencies. So cumulative frequency will be summing up. Here, the first one, you have a 5. There's no previous frequency, so it's just 5. For the IQ score, the second class between 90 to 99, you have the 6th one, but you have the previous one as well, previous frequency. So you're going to add them up, 5 plus 6, which give you 11. So it will be 11, 5, 11. Now the next one will be summing up all these, 5 plus 6 plus 4, or 11 plus 4. So cumulative frequency for the class between 100 to 109 will be 15. 110 to 119, you can see the idea. 15 plus 2 give you 17. Last one, 17 plus 3 give you 20. Now, I want you to pay attention to this number here, 20. What does that mean? this is actually your whole entire sample size. If you add up all these columns, that will give you the entire data number or the sample size. So your last column or last row of a cumulative frequency will always match up the total sample size. Relative frequency was the proportion. So you take class frequency divided by sum of all frequency. So I'm gonna have a class frequency for 80 to 89 was again 5. So it will be 5 over whole set 20. You can leave it as a fraction or you can give it as a percentage. How do you take the percentage value? 5 divided by 20 times 100, right? So 5 divided by 20 times 100, that's equal to 25%. So I don't mind leaving as a fraction or percent. On WebAssign, they will tell you whether they accept the fraction part or the percentage, so make sure you follow the instruction. Next one for class 90 to 99, this will be the 6 divided by 2. Where am I getting the 6? Again, from the class frequency. If you convert that, that's a 30%. 4 out of 20, which is 20%. 2 out of 20, 10%. Last one, 3 out of 20, which is 15%. Okay. Now, again, remember, if you're going to be adding up all this number, it has to add up to one number. It's the whole entire set, which add up to 100%. Cumulative relative frequency. So word cumulative will be summing up. What are we summing up? Relative frequency. So I'm going to be summing up this column. You can again leave it as a fraction or percent. First one, 5 out of 20 because there's no previous frequency. The next one will be 5 over 20 plus 6 over 20, which give you 11 over 20. Next one, 5 plus 6 plus 4, which is basically summing up these. So 15 out of 20, 17 out of 20, 20 out of 20. Again, this part summing up 20 out of 20 should be one whole. Okay. Pie chart. Let's say you have these data. I'm just using the same IQ score as an example. You can arrange the data in a pie chart, organize the data in a pie chart. What is a pie chart? Pie chart is a circle graph, and then you divide up the portion and then shade it accordingly. Bigger piece of pie represent more data. In order to construct pie chart, you must first convert the distribution into relative frequency distribution. Identify each section with the relative frequency. So pie chart is giving you the relative frequency value. What was the relative frequency value? Percentage. So you can see that everything data in here, it represents the percentage. So each piece represents percentage. Whole pie represents 100%. Bar graph. This is a graph that uses bars of equal width to show frequency of categories or relative frequency. So bar graph can use either frequency or relative frequency. So pay attention to the vertical scale. If it's a frequency, remember frequency is like that whole number. Okay, the count, actual count, not the portion of a data. If this gives you a relative frequency, you have to interpret that each bar represents the percentage value, not the actual count. Okay, the vertical scale represents the frequency or relative frequency. The horizontal scale identify different categories. The graph may or may not have gap. So here you have a 85, the IQ score. How many counts? 1. 87, 2. 88, 1. 89, 1. So 1 plus 2 plus 1 plus 1, that's a 5. And you can look at the next one. represent 90 to 99. So that's this, 90 to 99. This many. 1, 2, 5, 6, right? Because 1, 1, 3, 1. 1 plus 1, 2, 2 plus 3, 5, 5 plus 1, 6. So you see that's 6, and so on. Pareto chart. What is a Pareto chart? This is a bar graph for qualitative data where the bar are arranged in order according to frequency. Tallest bar is the left and the smallest bar are the right. This organization focuses on 10 or more important categories. Pareto chart is a very similar to the bar. It is actually a bar graph, but it's for qualitative data. What was a qualitative data? Those are the names and labels, not the numbers. Okay. And then there's one more thing involved. You are going to be arranging the order of a frequency. So the tallest bar is on the left and smaller bars are on the right. So here's an example. I survey people and then I want to know the favorite color. So I'm just making a number. So pink, there were 5 data. Blue, there were 10. Red, 3. And then green, 4. Okay. Then you're going to be creating a bar graph. Names and labels only. So here's the color and then here is the frequency. Your first bar is the tallest bar, so it will be the blue one. Okay, so you're not gonna put pink, blue, red, green in that order. You're gonna put the blue one first. Let's say this is 5 and this is 10, and then create a bar graph according to that. Oops. My phone rang. Okay, so blue. The next one is pink, 5. The next one is a green, 4. And then the last one, last one, which is red. You're gonna put the smallest bar over here. So you see the highest one and then tallest bar. So you see the little bit of a decreased one. Why do we do this? Here, because it's a names and label, it really doesn't matter which one we put at first. So you can see that if we rearrange from tallest to smallest, it tells you, oh, blue was the favorite color. The next favorite color is a pink. It's really clear and then easy to see. Whereas try to rearrange the bars here. So you put 96 first here and then 87, 101, 103. Well, you can see the bars and then see the highest one first, but this number will be kind of out of order. So it will be very confusing. So the only thing that we arrange order from the tallest to the smallest is for the qualitative data, which is names and labels. Okay. Okay, here's the last section of chapter 1.4. We talked about very briefly about each things, about how to organize data, what types of data, how to gather the data, right? Sampling method. So here's few terms involving experiment. How do you conduct an experiment? So few terms. In an experiment, we apply some treatment and then proceed to observe its effect on the subject. There's a difference between data collection and experiment data. We just gather the data. How much do you weight? Okay, you weight the person and then you mark. Whereas experiment, you are giving some kind of a treatment and then see that treatment affects the patients or the subject. Okay, so there's some kind of a treatment involved. When designing experiments, we consider randomization. That means selecting samples randomly so that data is not biased. Data is not biased. Okay. Replication. Replication means repetition so the result can be confirmed. Can be confirmed. Why do we want to do the replication or repeat an experiment? Okay, let's say you create a pill to help people lose weight. So you're claiming that, oh, if you take this pill for a month, you'll lose about 10 pounds. Okay, so before you actually sell it, you have to do some, experiment, right, to make sure that it does lose 10 pounds. So let's say you conducted an experiment first time. Well, it did lose, the patient did lose 10 pounds. So that's good. But you don't want to just rely on that 100%, right? You want to make sure that it works for all, right? So you want to repeat it again to kind of double confirm, right? Kind of like when you're taking an exam, you want to double check. So you are going to be repeating this to confirm the result, okay? Now, not all the experiment does go through a replication because there's a time, it takes double time and also twice as money. So replication is good, but time and then money involved. So people who are doing an experiment, they consider a little bit or for experiment, replication is good, but not all study does go through the replications. Okay. Blinding. What is a blinding? Blinding is when the subject doesn't know he or she is receiving treatment or no treatment. He or she is receiving treatment or no treatment. We call no treatment, another word is a placebo. Okay. Why do we not tell the group, oh, you're in a treatment or no treatment group? Well, it can give you a biased result. Let's say I'm in a treatment group and I know that I'm in a treatment group, then I should feel like I need to lose 10 pounds. So what happens? It can give you a biased result. So patient maybe in the treatment group may exercise more, okay? Whereas no treatment group, might not do the exercise. So it can give you some kind of biased results. So we don't want the subject know which group they are in. Placebo effect is when untreated subject reports an improvement. Untreated subject reports an improvement. Now this is not good. So I'm gonna put a sad face. So let's say, again, going back to that losing weight pill, right? You're in a placebo group. So you're not giving a pill, you're having a fake pill. You take for a month and then that person actually lose 10 pounds. Maybe because, oh, I'm taking the pill, maybe I have to lose weight. So they are be careful with diet and so on. So they did lose 10 pounds, but you don't want that happen. You want actually the treatment group to lose 10 pounds, not the untreated subject reports saying that they lost 10 pounds. So placebo effects is the one that you want to eliminate. You don't want that to happen during the experiment. Double blind. What is a double blind? Single blind was when the subject doesn't know. Double blind is both the subject and the experimenter does not know who is in treatment or placebo group. Both subject and experimenter does not know who is in treatment or placebo group. So why do we want this? Sometimes as an experimenter, you really want to see the result of treatment group losing 10 pounds because that's what you want to confirm during the experiment. So I may unintentionally pay more attention to a treatment group than not a placebo group because I want to see the result happening in a treatment group. So double blind help you eliminate that so that the experimenter is treating both treatment and placebo group equally. Okay. Last one, confounding occurs in an experiment when the investigator are not able to distinguish among the effects of different factors. We want to design the experiment in such a way confounding does not occur. So again, it's kind of similar to placebo effect. So untreated subject reports an improvement. So as an experimenter, you want to find out why that untreatment subject lost 10 pounds, but you could not figure out where the subject lost 10 pounds. That's called confounding. Okay, so this occurs when the investigator are not able to distinguish among the effects of different factors. So again, you don't want the confounding to happen during an experiment. Okay, so this is basically all for the chapter 1. So there are a lot of terms and definitions. Starting chapter 2, we'll go through a little bit of a calculating part. Okay,